All right, so electronic flight displays. Um, this is not the system that we have in our aircraft, but this is the G1000 system. It's pretty, I just like the graph. Um, we'll tie it into what we have in a sec here. But with most electronic flight displays, the screens in front of you are really just monitors. If you think of a PC, right, we have a computer and then we have a monitor. These two screens right here, PFD and MFD, literally just TV screens with buttons on them. That's all they are. They don't do any thinking whatsoever. The thinking is done in all these other things. Every single one of these boxes are called LRUs. LRUs stand for line replaceable units, which means that if any one of these breaks, all you have to do is unscrew it and plug a new piece in. It's like a Lego piece. There's really nothing too advanced to it. It's a plug and play essentially. Instead of a six-pack instrument, if it breaks, you have to take it out very cautiously, very carefully install it and find a new calibration and all that stuff. And all these things, plug and play. Anyways, PFD stands for primary flight display. This is where your flight instruments are, attitude, heading, whatever. MFD, multifunction display. Most of your nav stuff, it's usually a moving map, weather information, or any other information that isn't the primary six-pack instruments is on the MFD. Your main components of most electronic flight displays are the ADC, AHRS, and magnetometer. All these other ones we won't really care about for now. But talking about the ADC, typically when talking about an ADC, it controls four things. Pilostatic instruments, so airspeed, altitude, and vertical speed. Also the outside air temperature. So it takes all air data and converts it into computer data. And then from there, this is the computer, this is the brain. It sends that information into your screens. AHRS. AHRS stands for Attitude Heading Reference System. Another way to remember what it does, it controls attitude, heading, rate of turn, and subskid. The reason why this box right here doesn't say heading is because, typically speaking, magnetometers are separate from the AHRS, but they typically connect into the AHRS. This just means that if the AHRS breaks, you're not going to have any four of these. So no attitude, no heading, no rate of turn, no subskid. But if just the magnetometer breaks, just no heading. But you have all the other three. That's all it means. But inside the AHRS, according to Garmin, generally it's going to be rate sensors, tilt sensors, and accelerometers. Sometimes they say inertial sensors. They don't really want to tell you their trade secrets. Just a bunch of fancy solid state sensors. There's no physical gyros inside AHRS. The magnetometer, generally speaking, this is going to be located in one of your two wings. And usually it's in the wing because it's away from all the electrical equipment inside your plane, like radios and stuff that can interfere with getting magnetic courses and all that stuff. But how magnetometers work, if we go to the P-hack here, 8-20, 8-21, you can read through the fluxgate system, how it works, but the most important thing is we go down to this graph. So it's a coil. There's three little coils, maybe more, but this is the diagram you get. And the system passes AC current through, meaning that it's like a sine wave, it goes up and down. It's not DC current, it's not battery power, it's just one stream of energy. It's wavy, right? So AC current, there's peaks at the top and then there's troughs at the bottom. At the very peaks and the troughs, the coils get magnetized, but right in the middle there, when the charge is zero, is that as the current reverses between peaks, it demagnetizes, and the frame can accept flux from the Earth's field. So once you hit zero on the current, or on the magnetization, you can accept the Earth's magnetic field and sense where north is. Essentially what this is doing is resetting the magnetometer every time AC current flows through it. So senses, doesn't sense, senses, doesn't sense, and just does that over and over again. With these coils, they don't move, right? They just sense which one senses more. So in this, we can see that more is coming from somewhere over here, north is probably over here, something like that. Or actually, yeah. Cool, so that's magnetometers. Moving into what's more realistic, like G5s. Here I have the G5 Pilot's Guide. You can search this up online. But if you go down a few pages from the start, we have a system overview. It kind of tells you how everything generally works, but not really. Very vague. Again, they don't want to tell you trade secrets, but if you go down attitude, right, it just says inertial sensors. That's very vague. Again, it's just solid state sensors. It's not physical gyros. So no tumbling, no nothing like that. The G5 itself doesn't actually have an AHRS AEC that are separate from each other. It's kind of just combined into one. So the G5 itself does its own computing. It takes data from the pitot-static system, computes that on its own. Same thing with the attitude and stuff. But it does have a magnetometer separate from it though. Here we see magnet, right, from the magnetometer. This is the part number or part name if you want to buy it. But yeah, that's from the wing, away from all the magnetic deviation inside the aircraft. How to know if your systems are failing. So if your, let's say, inertial sensors, right, if your inertial sensors fail, obviously we won't have attitude, we won't have basically everything the AHRS controls. These red X's will pop up. These red X's only pop up when the computer fails. If you have icing or anything like that, it will show exactly like a 6-pack instrument. Garbage in, garbage out. It's a dumb computer. It has no logic whatsoever. If you take off the pitot cover on, right, garbage in, garbage out, it'll show you 0 airspeed, no red X's. If bug flies in, same thing. Ice, same thing. So only if the computer fails does it show red X's. Let's see, anything else? Electric engine instruments. Going back to this actually. So if you were flying like a G1000 or some other fancier plane, maybe a plane equipped with the G3X, most of the time they have an engine airframe unit. All this does is monitor engine indication. So instead of having 6-pack gauges doing RPM, oil pressure, oil temperature, this unit is responsible for that. Again, it feeds into the screens. This is the brain. It feeds into the screens. But if you have 6-pack normal gauges, RPM, and all that stuff, then you don't have this.